Today's lesson comes from section 9.1, and as you can see, the title is Inverse Variation. And my goal for you today, at the end of this lesson, I want you to be able to really have a basic understanding of what we mean by inverse variation, be able to write the equation for inverse variation, or the function for inverse variation. And then at the end of the lesson, we're going to look at this idea combined variation and have a better understanding of what that means and how to use it in solving some problems. I think it's a good idea, before we jump into inverse variation, maybe go back to some familiar territory. Back in first semester, we introduced this idea of direct variation. And direct variation in equation form is y equals some constant we called k times x. And the idea behind direct variation, as you can see in my pictures, is that as one quantity, in this case x, becomes bigger, since we're multiplying by a constant, not zero, that means that y is also going to become bigger by that multiple. Okay, so we say that they have a direct relationship, or sometimes we use the phrase direct correlation. As one quantity goes up, that causes another quantity to go up by that factor. And in class, I used the example of a upper school cafe lunch function, where it costs everybody that buys a lunch $5 a piece. X could represent the number of people that bought a lunch in a particular day, and therefore Y would represent the dollars that were collected for all the people that ate lunch on a particular day. Well, it's pretty easy to see that as the number of people that eat lunch increases, that causes our revenue or money collected to increase. And as that number drops or decreases, it causes a resulting drop in revenue. So these quantities, x and y, have a direct correlation relationship. Okay? Well, that's direct variation. So let's just do a little compare, contrast with inverse. We'll get to inverse in just a second. I do have one more slide. Remember the direct variation graph, which you're not going to have to do today. I just wanted to, again, give you a little comparison. Direct variation, here's the equation again. It's really just a line. If you notice, it really looks a lot like slope-intercept form. K can be thought of as the slope. And in this case, we don't have a b, so b is understood to be 0, which means the y-intercept is where it's at the origin. Okay, so direct variation, the line for direct variation, the graph will always go through the origin, and its tilt, or we use the word slope, will vary depending on whatever k is. All right, so that's direct variation. Well, how do we contrast that with inverse variation? Well, I hope you're thinking maybe that the word inverse implies opposite. And so if direct variation involved the operation of multiplication, some constant times this quantity, causing these two quantities to move together, well, inverse variation will be just the opposite of that. It will involve the opposite operation of multiplication, which is division. All right, so this is the equation in general for inverse variation, or we sometimes use the phrase, this is the function for inverse variation. So the idea behind inverse variation is, as opposed to direct variation where the two quantities move together, as it were, or inverse variation, as one quantity increases, it causes a resulting quantity to decrease, or vice versa. As one quantity decreases, that causes another related quantity to increase. So these we say they have an inverse relationship. Okay, as you can see by the thumbs up, thumbs down. One will go up, which causes another to go down, or vice versa. Okay, so here's just a sneak peek of tomorrow's lesson, really. We're going to be getting into the graphs, but notice how different the graph of inverse variation is. It's actually in two parts. We call these branches, and we'll get into a discussion of how to graph these tomorrow. So now here we are with inverse variation. And again, this is the function or the equation in general that represents inverse variation. Notice the restrictions. We cannot obviously divide by 0. And we will never have y equal to 0. Right? K has to be some non-zero number. And so therefore there is no way to make y become 0 if k isn't 0. So that's going to lead us to a discussion on the graph tomorrow. And if I want to find what this constant is in the numerator, hopefully you can see how algebraically we came up with this equation, just multiplied by x on both sides. And this will help us, if we need to, find out what this k is, this constant that sits in the numerator of this function. So here's some real-life examples of inverse variation in action. As you drive, you fill up your tank, and as you take off driving, the longer you drive, the less fuel. So these have an inverse relationship. Theoretically, the more you exercise, the more weight you lose. So exercise increases, weight should decrease. As price decreases, then demand should increase. So again, these would be what is known as an inverse relationship. Okay, so now we get into some actual homework help problems. And your first 6 problems are basically going to involve this little activity. It's really just an exercise in getting you to write the inverse variation function, which once again looks like this. Y equals some constant we call k divided by x. All right, so you're going to be given the fact that x and y are in an inverse relationship, or they'll use the phrase vary inversely. They're going to give you 2 values, one for x and one for y, and it's going to be your job to find out what the function that models this inverse variation is. So your first step is find out what k is. And for inverse variation, we find k by multiplying our x, y values together, and that's pictured here. So I found out what k is. K is 0.42. Now remember what inverse variation looks like with variables. So really, it's a pretty easy job. Once we found out what this number for k is, we just replace k with it. And that ends up being our answer. So basically, 6 times you're going to be doing this. You're going to be multiplying, understanding that x and y have an inverse relationship. You multiply these 2 numbers together to come up with your numerator constant. And that gives you, just plugging that number in for k into the function will get you to your answer. Okay? Problem, I'm jumping around just a little bit, but this will help you with 3 of the problems for the homework, 13, 14, and 15. Once again, the book tells us that x and y are in an inverse relationship. They vary inversely. So really, these problems are going to involve 2 answers. We're first of all going to do like we did previously on the previous example. We're going to write the function that models this inverse variation. So remember, that's going to mean finding out what the constant of inverse variation is. And remember, to find that constant, we just multiply x times y. So in this case, 10 times 15 is 150. And so my first answer, we'll just break this up into maybe answer part A, writing the function. that will be y equals, remember, k, which is in this case 150 over x. So I just wrote the function that models this particular inverse variation. All right, now answer part B is this sentence. Find out what y is if we substitute 5 in for x in this function that you just wrote. Well, that's pretty easy. If I substitute in 5 for x, I'm basically simplifying this fraction. And my answer, part B, is 30. All right, so I just want to point out that really this is a two-part answer. I want you to come up with the function in general, and then part B is use the function for the given value for x. Okay, letter B, same type of deal. We're going to write an inverse variation function, so I'm just going to write this out again so you'll just keep seeing it over and over. This is what inverse variation looks like. So k, our numerator, is found by doing multiplication, 30 times 2, which is 60, over x. So that's our answer, part A. Answer part B is take that function that you just wrote and come up with a number for y if you let x be 5. Well, obviously 60 divided by 5 is 12, so my answer, part B, is 12. Okay, one more of these. Again, here's inverse variation in general. So if I just have a number, constant to plug in for k, I'll have the function. And k is found by multiplying x times y. 6 times 30 is 180. So my function is y equals 180 over x. That's part A answer. Part B answer is using this function. If you plug in 5 for x, what comes out for y? 180 divided by 5 is 36. So I've given you some examples for 3 more problems that you're going to do on the homework, 13 through 15. Okay, problems 7 through 12, you're going to be given some tables, table of xy values, and it's going to be your job to identify the table as representing direct variation, inverse variation, or maybe neither. Okay, and then once you've come up with that determination, if it's direct variation or inverse, you're going to write the function. If it's neither, then there is no function to write. I'm giving you a little hint here on how you can tell whether or not the table represents direct variation or inverse variation. And it's how we come up with k. For direct variation, we come up with the number constant k by doing division, y divided by x. For inverse variation, we come up with this constant. We've been doing this already in the previous examples. We multiply x times y. Well, let's just do a quick survey of this first table. Let's start with direct variation, y divided by x. If we do 0.7 divided by 2, okay, maybe you want to use your calculator to do some experimenting. If you do 0.7 divided by 2, then you do 0.35 divided by 4, you do not get the same result. And that's the whole idea. If this were direct variation, when I do this division, y over x, within each ordered pair, I should get the same answer. And that same answer would be k. Well, since I don't get that dividing y over x, then A cannot represent direct variation. Well, what about inverse variation? It says that I find k by multiplying x times y. Well, if I multiply x and y together, here I get 1.4. If I multiply 4 times 0.35, I get 1.4. If I multiply 14 times 0.1, I get 1.4. Well, sure enough, I get the same result every time I multiply x and y together, and that same result is called k, or the constant. Okay, so my first answer here is I've identified table A as inverse variation. And now I'm going to write the equation, much like we did on the previous examples. We found k, 1.4, divided by x. All right, so this is another one of those cases where you basically have two answers. Answer A is identifying, and then answer B, if necessary, you write the function. Okay, let's do something similar with table B. Let's see if it's direct variation. If it is, then when I do y divided by x, I'll get the same result every time. 6 divided by negative 2 is negative 3. Well, you can probably tell that 5 divided by negative 1.3 is not negative 3. All right. Another thing that you can observe is for direct variation, as x gets bigger, then y should also be getting bigger. Okay, and that's not happening. Well, x is getting bigger on the top, but y is not getting bigger. It's getting smaller. Okay, so we know direct variation not possible for letter B. So let's test inverse variation. Now we're going to be multiplying x and y. If we do that, we get negative 12. Well, going to the second order pair, if I multiply these two together, I do not get negative 12. Well, that's interesting. I didn't get the same result doing division, y over x, with every ordered pair, and I also didn't get the same k number every time I did the multiplication. So in this case, I'm going to say, well, this is neither. This is neither direct variation or inverse. And since it's neither, I don't have to come up with a function. Okay, well, let's try letter C. Let's start with division, y over x. Always do y over x. It's 5 over 2. Moving to the next order pair, I get 10 over 4, which reduces to 5 over 2. And then over here, 15 over 6 also reduces to 5 over 2. So I've discovered that this table C represents direct variation. And the k number that I came up with, the number that was the same result of the division every time, 5 over 2. So in direct variation form, it's y equals k times x. So that would be my answer for letter C. All right. And that takes us to the final 4 problems. And this is going to change our topic just a little bit, where we have combined variation. And this is just going to throw another variable in the mix. Notice we've got z varies jointly. When you see these words, varies jointly with x and y, I'm going to show you how you can interpret in an equation this sentence. Whenever you see z varying jointly with 2 other variables, whatever they may be, then that interprets like this in equation form. It's almost like both of these represent direct variation within the same function. Everything gets multiplied together. So z varying jointly with x and y, you'll get used to seeing that. That interprets in equation form like this. Okay? Now, if you'll notice, my next sentence contains values for variables. One thing that stands out to me is they did not give me a value for k. They gave me a value for every other variable in this equation except for k. Well, that's interesting. So that tells me I'm going to have to use these numbers to find out what k is. Okay, so let's do that. If you replace z with 7, again, we don't know what k is yet, but by knowing what all the other variables are, we can solve for k. Okay, so we got 7, and I'll just turn that around, equals 4k. And if you divide both sides by 4 to solve for k, you get k is 7/4. All right, so now I'm able to write the actual function. This was just setting it up with just variables, but now that I know what k is, I can write the actual function. All right, z is 7/4 times x, y. All right, now I've this is another two-parter, so you got to be careful. Think of this as part A, writing the function. And then part B, well, what is the value of z if we replace x with 4 and y with 8 in this new function that we just came up with? Well, let's find out. Z is equal to 7/4 times 4, which is x, and 8, which is y. Okay, just doing a little math here, we get, just multiply left to right. If you multiply these first two numbers together, 7/4 times 4 is just 7. And then 7 times 8 is 56. So that would be my answer, part B. All right, A is give me the function. B, again, use the function for given values for x and y. Well, that's the example that says varies jointly. Just think of all multiplication. Z is going to be equal to the constant times x and y. All right, well, let's look at another example where the wording changes a little bit. This is a combined variation which has direct variation and inverse variation within the same function. All right, so let's interpret this first sentence. Z varies directly with x. I'm just going to write that part down. Because direct variation means multiplication. And then it says it varies inversely with y. Well, remember, inverse variation implies division. So it's like we combine both of those operations in the same function. Okay, so this is kind of a template. And now find k by using these numbers. Okay, notice how they give us z, x, and y, everything but k. So replace everything except for k. And that's going to help you find what k is. You can solve for it. Multiply by 2 on both sides. Divide by 5 on both sides. And now we're able to get more specific. This is very general. There are no numbers in this at all. But now that we know what k is, we can write the actual function. Okay, so this would be my first answer. And now I'm going to use that function, this blue function that we just came up with, to find out what z would equal if we replaced x with 4 and y with 8. And hopefully you can see pretty easily 16 divided by 8 would be 2. So that would be considered the answer part B. Okay, so combined variation, you will see the words varies jointly. You're thinking all multiplication. Z equals the constant times x and y. X and y are working together. Here they're working in opposite directions because one is varying directly, that's multiplication. The other one is varying inversely, that's division. All right, so hopefully that helps you with the examples 24 through 27. And this is the entire assignment, and work on most very hard, and we will check these out tomorrow.